right. Thanks for coming by today. I know it's like 5 o'clock now. You've probably sat through like 6 talks or a million. Your brains are fried, but don't worry. There's only 110 slides left today. My name's Gabriel, and I'm a software engineer at Airbnb. I work on Android. In the past, I've done some React Native there as well. I also wrote Lottie for Android, which we'll learn more about today. And before that, I worked on Android Auto on the Android team at Google. So before I get started, I just want to mention that we do have a live demo. I'm not going to be coding, thankfully, because those never work. But what we are going to do is build an animation, and you're actually going to get to try it on your phone. So at some point during this talk, go ahead and download the Lottie sample app. There's one on the Play Store and one on the App Store as well, whatever kind of phone you have. The one on the Play Store is written by me. It is an Airbnb app. The one on the App Store for iOS is not, but it works just the same. So I want to talk about what we believe when it comes to animations and design. And we believe, first of all, that shipping animations should be just as easy as shipping static assets. I'm sure in the past, if you've built apps or any sort of product, you've worked with a designer, and at some point they've given you an icon or an asset. You just drop in the file, and you render it. It's no problem. You don't even have to think about it. You let them focus on the asset, and then you just drop it in the app. We also believe that it should be cross-platform. In many cases today, even with a static asset, an animator or designer has to go and export it with like PDF or whatever, like 3 different densities for PNGs, whatever it might be. They may have to export 6, 8, 10 files for different platforms. They need to understand them. They need to do it right. And it's a big pain. So we believe that whatever we do should be cross-platform. Specifically with animations, let's take a look at this animation. We're going to look at this one a lot today. We're actually going to build it later. But let's go back to 2015. This is before we shipped Lottie. Let's say you're building a product, and a designer's like, we need to ship this in our app. What do you do? Well, you might think, OK, we'll just write it. We'll write the code. So first of all, there's a translation layer. You might not get it right. But for something complex like this, you have to hand create everything by hand with a tool that was not designed to build something like this. It could take weeks, if not a month, of just engineering time just to get this one animation right. God forbid if you have to change it or update it at some point in the future. You might do a PNG sequence. So let's say you had like a 2-second loader. You might have like 60 individual PNG files that you need to load into memory and render and rotate through. Not only is it huge, but they don't scale. And if you want to get it right across different densities, you need to ship 200, 300 plus PNGs just for this small animation. You could do an animated GIF. You see them all over the web. They're actually hugely inefficient storage-wise. They're like 10 times the file size they need to be. They also are pixelated. They don't support transparency. Lots of problems there. You could do an MP4 file, video. You have a lot of the similar problems as a GIF. It doesn't support transparency. It doesn't scale without getting pixelated. Really, the only thing you gain there is that the file size is slightly smaller. But basically, all these options suck. And eventually, most animations like this would get punted. You just wouldn't ship them. In fact, when Google launched Material Design, they had a lot of reference documentations with animations and logos and empty states and loaders and everything you can imagine. And even in their own first-party apps, they still shipped static assets. So let's fast forward to today. We have shipped Lottie. You designed this animation with After Effects. In many cases, that was a tool that you already used. But now, if you were to design in After Effects, you can export it with JSON, send that JSON file to all your engineers, and they can drop it in the app just like that PNG. And even better, it's always that one file. You don't have to worry about different densities. It'll scale to any size. It'll never be pixelated. It supports transparency, so you can do overlays. You can basically do anything you want. It's cross-platform. We'll cover that in a second. And the file size is really small. This is a minified JSON file. It's not designed to be human readable. It's designed to be small. So this actual animation, the entire thing is 230K. The equivalent 2x GIF is 1.1 megabytes, and the PNG sequence is a megabyte. And you can imagine a lot of devices these days are now 3x or XXX HDPI on Android. You would see that 2 or 4 times this file size. So what is it? How did we do that? Well, at a high level, You create something in After Effects, Illustrator, or Sketch. You export it to JSON, and then you render it with Lottie across all your platforms. Most of you in this room are engineers. You may not be familiar with After Effects. After Effects is kind of like an IDE for animators. It's UI-driven. So there we go. If we zoom out a little bit, you'll see that you build the animation. It's very visual. You have lots of tools for dealing with time and shapes and space. Again, we'll learn about some of these things going forward. Or Sketch. Sketch is not a motion graphics tool. It's actually, people use it for layouts, wireframes. They also use it to create vector assets and static assets, so like icons and whatnot. I mentioned that you export it as JSON. This is what that JSON looks like. It's minified. It's not meant to be human readable, but as you can see, it's a bunch of numbers. It's a bunch of information. It contains colors and vectors, and we use this information to recreate the animation. Then comes Lottie. Lottie are the renderers for each platform that actually take that JSON and make it real. We have the first Lottie renderer was web. It was just an After Effects plugin and web. It used to be called Body Movin'. Now it's called Lottie Web. And then there's Android, iOS, and as of this week, announced at the Build conference going on right now, Microsoft is building Lottie Windows. So you'll be able to see Lottie on the Microsoft repo on GitHub as Microsoft/Lottie Windows. There's also wrappers for everything under the sun, from React Native, Xamarin, NativeScript, Titanium, React, Vue, Angular, you name it. When I say cross-platform, I really mean it. We want native renderers on every platform with wrappers for your native toolkit. So who is Lottie? It's kind of a weird name, right? Lottie is named after Charlotte Reiniger. Charlotte Reiniger is a pioneer of animation. She did her first work in 1919. This is about a decade before Snow White came out, which is generally thought of as the pioneer of animation. So this is a nod to her. Let's talk about who's using it. This is an Airbnb-made thing. We made it, but if we look around the App Store, around the world, around the Play Store, this is just a small sampling of the apps that are actually shipping it in production today. So based on all these apps, particularly because Google's using it across a lot of their phones, Samsung is using it on many things, you probably all have some form of Lottie on your phone right now. Just yesterday at Google I/O, it was blessed on stage by Romain Guy, basically the graphics expert of Android. He basically invented it, basically blessed Lottie. He said, you know what, we're not going to try to do something like this because the community has already built something that can do it. So let's walk through what it can do. Lottie's used for a lot of different kinds of things. It's often thought of as just animations, little icons and whatnot, but there are actually a lot of different use cases that people are starting to use it for. So here's an example from the Google I/O 2018 app of how they're using Lottie as a countdown timer to indicate how much time is left. Walgreens is using it to do an introduction to their app to show you some of the things that you can do. Target is doing something quite similar. And then here's one for Raise Me, which helps people get scholarships for education. And the walkthroughs like this, again, based on some of the things I already covered, would be basically impossible to do without something like Lottie. And then you can also do things like tie it to scroll events and make them really interactive, so they can change and feel like it's actually part of the software, not a video playing on top. Again, here, it's tied to the scroll events, so it feels very, very fluid. Of course, it can be used for animated iconography. So here are a couple of examples of how we use it at Airbnb, to take what normally would be a static icon, and we add some delightful touches to make it a more rich experience. Con.io it's an Italian bank. They're doing something similar here. And then we also partnered with John Caserta and Salih Abdul Karim, who's a designer at Airbnb. So this was an original project that was part of the Noun project, which is a collection of icons on the internet. And we did a partnership with the Noun project and him to animate them and make them come alive. You can also do animated illustrations. Here's one from Instacart. Again, here's one from our app. Or animated logos. So for a splash screen or some introduction, you can really make your brand pop. Here's the Google Home app. This app actually won a few awards. They have a collection of like 30 or 30 plus animations that they use Lottie for. For every setup screen, animation, all over their app, they're using new kinds of animation and delightful touches to indicate what's going on. And again, in Eero, they're doing something during the setup of the routers where there's different stages of finding the router and configuring it and connecting it to the internet. They've used collections of Lottie animations to loop through indeterminate progresses, to move between different scenes, to make delightful touches. If some of you were at the talk earlier this morning about perceived loading time, some of these animations like this can make extended delays or long periods of loading feel much shorter and less perceptible to users. You can even use Lottie for static assets. So today, the New York Times actually uses Lottie to render the New York Times logo in their app. And I'll actually get to why in 1 second. You can also use it for splash screens, loaders, anything along those lines. And because it's JSON, you can download it over the internet and get it from an API. So here's an example of something that we're working on where when you book an Airbnb, we'll ship you an animation that's specific to the city that you just booked. This is completely unfeasible in any other environment without Lottie because either the file size is too big or you would have to ship them all with your app. And then as of Lottie 2.5, which recently came out, it actually has dynamic properties. And so New York Times is using Lottie to ship one asset for their nameplate, but they're theming it and they're changing the color from white to black depending on whether it's day mode or night mode. Here's a little demo I threw together where you can actually go in and tweak individual parts of an animation. So you can change colors, you can change the speed of an individual part of an animation, you could tie it to download progress, you could tie it to accelerometer, gyroscope, anything that you can think of. You can change the stroke width, you can change the height of his jumping, anything that you want within an animation, you can go in and tweak in real time. So this opens up a whole new world of possibilities. Actually, it was less than a week after we released Lottie for Android and iOS that the community actually built a website called lottiefiles.com. They continue to maintain it today, and it's a collection of animations built by the community that are available for anyone to use. They also have a feature where you can create a profile or drag your own Lottie JSON onto it and preview it, so a lot of designers use that to test the actual animations they create. Since it came out, there are over 400,000 downloads of animations in Lottie files. There are over 1,000 animations on it available for you right now. And there are over 250,000 previewed animations just on Lottie files. So let's talk about how it works. I showed you this animation of a city, and I told you we're going to look at it a little bit more. So let's actually break this down. And in order to do that, we have to understand the concept of a language. So right now I'm speaking English. I think most of you probably understand that, or you would have left already. Java, again, another language. It has its own individual pieces, like if overrides extends. Or maybe now you're using Kotlin, which has good vibes and love and happiness and like an exclamation mark, maybe even two. We all love it. And then animation. So this one might be a little bit less familiar to an engineer who's never worked in the world of design before. So they think in things of interpolators and strokes and mats and masks and keyframes and color spaces. So we're going to dive into some of those today. So now when you work with designers, you have a better understanding of the world that they live in. So what's an animation? An animation is three main parts. It's a shape. That shape changes, and it changes over time. So let's walk through it. Let's talk about the shapes. So here we have, as part of the animation, we have a cloud. Let's zoom in, enhance it, and let's figure out how this cloud is made. Remember, this cloud is made from some of that stuff that was in that minified JSON file. And the important concept behind it are these Bezier curves. A Bezier curve is 4 points. There's a start point, end point, and 2 control points. And with those 4 points, you can basically create almost arbitrary curves between any 2 points. So if we go back to the cloud and we want to build it out of Bezier curves, what does it look like? So on Android, the API is path. You have a start point, and then you draw a series of Bezier curves one by one, and slowly you build up a cloud. So you can see with something like this, you can basically create anything if you get those numbers right. And that's why designers use After Effects, because they have the tools needed to create it visually, and then we use those numbers under the hood to make it automatically look correct across every platform. So a shape by itself actually doesn't do anything. If you were to just create a shape in After Effects and export it, you wouldn't see anything. What you actually see is a fill. A fill is separate from a shape. Unlike many design tools where a shape has a fill property, they are separate concepts in After Effects. So here we have an example where we have 3 contents in the layer. We have a red, 50% blue fill, and a rectangle. So what's going to happen is After Effects is going to walk up this tree. It's going to find red. Red is something that actually draws to the screen, and then it's going to draw all the shapes above it red. It's then going to walk up from there. It's going to get to the 50% opacity blue. It's going to draw all the shapes above it. Then you wind up with a purple shape. Again, this is not something that would be possible without fills being a separate concept from shapes. But this is how After Effects works, and it's quite powerful. Then the rectangle, it's just a shape. Again, it doesn't do anything by itself. So what you wind up with in this case is a purple square. Strokes are kind of like fills, except it's only on the edge of a shape. You can control things like its width, but that's about it. It's very similar to a fill. Gradient is kind of like a fancy fill. Instead of just one color, it changes from one color to another. In fact, in After Effects, gradients are more powerful than that even. You can actually have a gradient that goes between many different colors. You can move the midpoint around so that the actual speed at which it moves between different colors changes. So you have a lot of power there. A gradient can also be linear, which is like the top one here on this slide, or radial, comes out from the center. And you can even apply a gradient to a stroke. So how do we actually do that under the hood? On Android, it's a little bit unintuitive at first. For a fill or a stroke, it's pretty simple. There's this paint object, and we can call set color. This is a color int. It's like the bitmap of all the RGB channels and the color. Pretty simple. But this is clearly not enough information to show a gradient. You might think that, okay, maybe there's like a set gradient API, but there's not. But if you look around, you'll see that there's this thing called linear gradient and radial gradient that extend shader. And there is, in fact, a set shader API on Paint. So for those of you who aren't graphics experts, you may not be familiar with the concept of a shader, but it's basically like a little pure function in which it's given an x and a y coordinate and it returns a pixel color. This works super well for gradients because it's always the same for a given pixel x and y coordinate. And it can also be super parallelized on a GPU, which is why it's done this way. So we use this linear gradient shader and radial gradient shader to get shaders working on Lottie. Sometimes there are dashes. So here we have a fun little billboard shimmer effect on the stroke of this billboard. And we use something called a dash path effect on Android. It has 2 values. It has an array of gaps and dashes and also an offset. So the array in this first, the top left circle, you'll see it's 20/20. That means 20 pixels of dash, 20 pixels of gap. If we do 20/40, the gaps will now be twice as long. Or if we increase those numbers to like 200/200, you'll see those dashes are much longer. We can then use offset to determine where that first one starts to achieve that shimmer effect we saw on the previous slide. Trim paths. So here we added some fireworks. Let's zoom into one. You'll see here we use something called trim paths to actually only render one segment of a line. Here's some fancy code, but we basically use this API in Android called path measure, and we do some calculations based on what the intended behavior of the animation is to get a segment of the path and only render that. And here we have a mask. So there's a moon here. If we zoom in a little bit, there we go. Let's start with just a bunch of dots. Okay, so we have a bunch of dots, and somehow we're going to get a moon. First thing we want to do is take a circle and punch a circle out of it. And then we take another circle, and we kind of do the opposite, and we like inverse punch a circle out of it. And we wind up with this crescent shape. And that uses this concept of a mask, where you take a shape, and you only render that part of a different layer. And then you can do a subtract mask to get the cutout for the inside of the crescent. There's a similar concept to a mask, and it's called a matte. So masks are shapes that are attached to the layer itself. But a matte is an entirely separate layer, okay? So on that inside of that layer can be like fills, and there can be more shapes, and anything that we talked about to make up a picture can be on a separate layer. But that entire layer is then rendered and then used as essentially the mask for another layer, but it's controlled independently and it's much more powerful. So this is a little bit of a more complicated concept, and it required quite a bit of extra work to get right on Lottie. So let's talk about it. Since I wrote the Android version of Lottie, that's what we're going to focus on today, but it's a similar concept for each platform. So in Lottie, we draw something called a canvas. There's this weird API, it's called saveLayer. Okay? So let's say we call canvas.saveLayer, and then we draw something. What happens? Nothing happens. All the drawing effects kind of disappear once we call saveLayer. But when we call this other API called restore, they all come back. So like we just did these two things, but nothing actually changed. And it turns out that the key piece of this API is this paint object. And in particular, on this paint object, there's a property called a transfer mode. And Android comes with a number of transfer modes called porter.dov transfer modes. Here are a few examples. So if we take a destination image, like a red circle here, and a source image, which is this blue square, if you combine them with different transfer modes, you get a different output. So you can see, depending on what effect you want, you use different transfer modes, and you wind up with what you expect. But you can do very advanced drawing and animations with this. So let's actually take this abstract concept, and let's actually walk through it step by step. So in this case, let's draw a red star. So in practice, I don't actually recommend using this method to draw a red star. It's a contrived example because that save and restore layer is actually quite an expensive call, and we'll see why in a second. So, and again, because it's expensive, we have a lot of optimizations in Lottie to make it better, but it basically, the expensiveness of that call is proportional to the size of the layers that you're masking or matting. So if you are, in fact, using these in your animations, it's fine, but do try to minimize the actual bounds of the shapes that you're using as a mask or a matte. So let's walk through it. So we start with this blue background. We've already drawn it on a previous layer, so we're good there. So the first thing we do is we call saveLayer, same saveLayer we called before. Now we're going to draw a red square. Again, we're trying to get to a red star, but right now, red square, it's a little bit bigger than we want, not quite the right shape. That's fine, we'll fix that in a second. Then we call saveLayer again. So what's happened here is that first thing you notice, if we go back, you'll notice that that red square is not on the main screen of the phone. That saveLayer call actually says, hey, pause everything you're doing, now redirect all drawing calls to an off-screen buffer and draw them there instead, okay? Then we call it again, and now it's like drawing inception. We've gone 2 layers deep. Now we're drawing to a second off-screen buffer that's even further away from the main screen. And from there, we'll draw a star. Now, this star, it doesn't matter what color it is, because again, for a mask, it's just a shape. All we care about is the shape. As long as we draw it, it can be black or blue or red. Doesn't matter, but we get the shape right. And then we call restore layer. And thinking back to that paint object with a transfer mode, it turns out that destination in gives us the one that we want. So we restore it with a transfer mode. Now we have a red star on one off-screen buffer. And then we call restore again, and it goes back to the main screen. The second restore call is actually not drawn with any transfer modes because it already has the correct content. But the reason why we need to do this additional saveLayer call is because if you render other things on layers prior to this masked layer, those would be masked unless we draw that current layer to the first off-screen buffer. So it's really important that we do both of these calls. Lottie also supports text. Here's an example. This is an actual animation rendered by Lottie. It supports, the actual text support varies a little bit platform to platform. The web support is very good. Android support sort of in the middle, and then iOS and Windows, not quite there yet. But at least for the platforms that do support it, it supports things like custom fonts, kerning animations. You can replace text at runtime, so if you want to use it for something like a username, a score, the weather, battery life, anything like that, totally fine. You can even use it for something like internationalization. So great. We learned a lot about shapes. We can make any static asset in the world that we want. You can speak the language of a designer for static assets. But we're not quite at the world of animations yet. So let's talk about how we change those shapes in an animation. So here we have, simple example, we have a red square. Again, our favorite red square. So you can do a couple things to change it. You can move it, you can scale it, you can rotate it, maybe some combination of them. So how does this actually work? We call them transforms. The collection of them is called transforms, but it's quite interesting. And we're going to dive into just a little bit of linear algebra. I promise I'm not going to bore you too much, but we're just going to touch on it in case either you need a refresher or maybe you haven't actually covered this, this linear algebra part of graphics. So let's say you have a pixel, x and y, and you want to translate that pixel by tx and ty. Well, it turns out that if you craft these linear algebra matrices in this such a way such that you have a vector for your current pixel, and then you have this 3 by 3 matrix on the left with your tx and ty in positions 3 and 6 in the matrix. If you multiply them, this new matrix that you're left with is x prime y prime, where x prime is x plus tx and y prime is y plus ty. You can actually walk through the linear algebra multiplication if you're interested. It works. You can just take my word for it. And it's kind of cool. If we actually extend this concept, it turns out that there's another special matrix that works for scaling. So it's positions 1 and 5. You put your scale x and scale y, scale it up. And same with rotation. This one's for 4 values. But again, not surprisingly, for rotation, you have things like sine and cosine of your theta. Turns out, we can actually just smash all of these together into one big matrix, and we call this the affine transformation matrix, in which we take a matrix and we can apply any sort of transform to an existing shape. Turns out that this concept is fundamental to the way that Lottie works, the way that it changes, and the way that it animates over time. On Android, there's actually an API called Matrix. And this matrix is a special graphics matrix because this thing is super, super common. It's highly parallelizable. So they actually just made an API for it. And you can do things like pre-translate, pre-rotate, pre-scale. You can combine them. You can concat them. You can do all kinds of things. Again, these are critical for Lottie to work. In fact, it's somewhat interesting. A side note, I guess, is that on Android, hardware-accelerated layers are not anti-aliased. And so if you have a layer that's scaled up a lot, or if you draw a shape, then you scale up the canvas, and then you render it with a hardware-accelerated canvas, it'll be pixelated, even though you drew a vector. So it turns out Lottie before 1.5, I think, it actually used to kind of scale and rotate and do all these transforms at every layer as you're going through children and parents and whatnot. But what would happen is when you turn on hardware acceleration, even though you're using a vector graphics software, you would actually see lots of pixelation, and it would be very, very bad in certain cases. So now, Lottie actually takes this transformation matrix, and it continues to pass it all the way through from the first root all the way to the last child, concats the matrix along the way, and then only applies it directly to the shape that it draws to the screen at the end. So no more scaling problems. Let's talk about parents. So here we have the house, and it has a door, it has a roof, and it has some windows. Now, if you look carefully, you'll actually see that those things, they move just slightly off from the actual movement of the entire house. You could totally do this by hand. You could have a curve for the house, and a curve for the door, and a curve for the windows that are all in global absolute coordinates, but that would be a huge pain to actually do. Let's say you wanted to like move the house or like slightly change it, make it feel better, you'd have to redo everything for everything else that's around it. So with parenting, you can actually just say, hey, this window is literally like stuck to the wall of this house. Whenever the house moves, it moves, and its movement is now relative to its parent. And thinking back to that matrix thing we just talked about, it turns out that's super easy when you're dealing with matrices, because instead of starting with an identity matrix for the window, you actually start with the final computed matrix of its parent, and then go on from there. And then it just works. It's like magic. So now we have animations, we've built shapes, we know how they can change, and it's really important to know how they change over time. So again, one important thing about Lottie is that we have some vector information, and the files are pretty small. That means we don't actually have every value for every frame. So, but it still renders at 60 frames per second. It looks pretty smooth. So we actually need a way to go from point A to point B, whether it be a color, a shape, a translation, a rotation, whatever it might be. And so basically, you have a point A and a point B, or a value A and a value B, and you need to move between them. You can linearly move between them over time, but as some of you may know, that's not always the desired effect. Not only does it not look good, but it might not be what the animator intended. And so we can actually create our own interpolator that says, as time moves from 0 to 1, actually run it through this little function that takes one range from 0 to 1 and translates it to another range from 0 to 1 at a slightly different rate. And this is how you do things like in material design. They talk about material motion, physical objects moving, things that feel like physics. Same concepts apply here. Color is quite an interesting one as well. So we talked about interpolators for lots of things. It's sort of like this with color, but a little bit different. So here we have a gradient. It goes from black to white. It looks fine, looks totally fine. It does the right thing. If you said you wanted a gradient and I gave you this, you'd be like, okay, looks good. However, if we actually break it down into chunks of even luminosity, such that the perceived color difference between each square is the same, you would see that the squares would not actually be the same size. And it turns out this is actually not ideal. We want it to look as perceived by our eyes like it's even, not just like 1, 2, 3, 4, 5, all the way up to 255 for each channel. It turns out that there's a little transfer function you can run that converts 0 to 255 to gamma and a luminosity that is actually based on how our eyes perceive the color. It's roughly x to the 1 over 2.2, or yeah, gamma equals 2.2, whatever. But if we run the transfer function over the gradient, then you actually get even bars. And it turns out that if you look at the gamma gradient in both of these cases, it looks way better, especially the color one. It becomes super obvious. If you're animating between two colors without doing this, you'll wind up with these browns and these muddy colors in the middle, but you get super vibrant, nicely evenly distributed colors if you do it through a gamma transfer function. So it's really important. You might not notice at first, but when you see them side by side, it's super obvious. So when we put it all together, we have a keyframe. The keyframe has a start value, an end value, start frame, end frame, and interpolator. This is the key building block for everything in Lottie. Nothing moves, nothing happens at all without a keyframe. It's the glue that holds it all together. And hopefully, at the end, it just works. And so I gave you some of these examples at the beginning. One of the alternatives to Lottie is a PNG sequence. I am sorry to all of you who had slow phones over a year ago, but we actually loaded almost 100 PNGs just to show you a loading spinner on the Airbnb app. I apologize. It's gone. We fixed it, but lots of apps still do this today. This is an actual PR. Thank God we don't live in that world anymore. It's terrible. Unfortunately, sometimes it doesn't just work, right? Especially when we're talking about After Effects. After Effects is like a 30-year-old program. It's super complex. It was built way before the time of smartphones. And in fact, it was not designed to build vector animations for Android, iOS, web, and Windows. It was actually designed as a video editing suite as part of the Adobe, what is now known as the Creative Suite, for video editing. So you can do things like special effects and fire, and you can write expressions with JavaScript, which do work on web because it runs JavaScript. They don't work on any of the other platforms. But lots of things work. Over time, we've built up a great feature set, so you can build a lot of things. But again, some things are not supported. So if you build an animation, doesn't look right, what do you do? So first, go to airbnb.io/Lottie. That's where our unified docs are for all the platforms. We'll be adding Windows there shortly. There's a list of supported After Effects features for every platform, so you can see what you can use and what you can't. And then after that, if it still doesn't work, you're still confused, we're all engineers. We know how to debug. We can do the same thing with an animation. It's not this terrible, scary thing. Look at it, figure out what's not working, break it down layer by layer, and you can often isolate the problem. And once you isolate it, you can often either work around it or then file an issue on GitHub with a very specific use case rather than having us like guess at what it was supposed to look like or spend a lot of time reverse engineering everything. Now you might be wondering, like people love tests. You probably heard a lot about testing today. We also have tests for Lottie. But you might be wondering like how we would do like a unit test or something like that for Lottie. And it's super important that we get this right. You saw on the slide earlier that hundreds, if not thousands, of companies around the world are shipping Lottie today. They're shipping it in very important things, like the Google search app uses Lottie for a number of things, and that's shipped to like something like 2 or 3 billion devices every week. It's super important that we don't break your animations. So we built a system for screenshot tests. where we have both an open source repository and a closed source repository of actual animations. The open source one is a variety of freely available animations, and then we have an internal one from our own product animations, but also product animations from other companies from around the world that we use internally for regression testing without exposing them to everyone through the open source repo. So first of all, if you have them, do send them to us at lottie@airbnb.com, and we can guarantee to not have rendering regressions for your animations going forward. But the way it works is it basically spins up an actual emulator. It uses Firebase Cloud Test Lab, and it runs all the screenshots for a number of different progresses from 0 all the way to 1, and it collects them, it uploads screenshots to S3, it creates this report, and it tells us everything that has changed. It's caught a number of things before they've been shipped, so it's been super helpful. So maybe some of you guys went ahead and downloaded this Lottie app. Hopefully you did. If you did, just go ahead. There's a preview tab, at least on Android. Go to scan QR code, and then I'm going to jump over to the biggest QR code I could possibly fit on a slide, and hopefully you'll be able to see the animation we just built today. So if any of this sounds exciting, or you want to work with me or any of my colleagues on this or anything else, we are hiring, where we have a lot of exciting things coming up. I tweet about any Lottie updates on Twitter, GPL8. I also have some stickers, laptop stickers, if you want those. But the important thing is we built this because we care about high-quality products. We care about animations. It was too hard, and we wanted to fix the problem. And it's been really successful for us. We want to help other people. We want to make richer experiences available on any platform for anyone. So without further ado, I will leave this up so you can continue to scan this beautiful QR code, but I'll open the floor for questions after. Thank you. Should I just read it? Yeah. OK. Performance in Lottie, great question. I definitely talked on the mats and masks thing. That is the #1 reason for performance problems on Lottie. And generally, like, if you can avoid using them, you should. There are times when it's very, very hard to make things without masks or masts. But so use them responsibly. Try to minimize. So basically, it computes the union bounds of the mask or mat and the layer that it's being masked or matted to. So keep the union of those layers as small as possible, and the performance overhead will be proportional to that. Lottie's pretty good overall at shapes and whatnot. These platforms are pretty optimized. On Lottie Android, there's an optional API to turn on hardware acceleration, so do try that. Also, in the Android app, the new one, we just recently relaunched the Android app, which some of you have now. You can open up an animation there. There's a real-time render graph where you can actually see the frame-by-frame performance of Lottie with little bars for 60 FPS and 30 FPS. It'll also tell you how many milliseconds it took to render each layer. So if it is slow, you can actually go to your designer, and you can be like, hey, this layer is particularly slow, and you can debug it from there. But generally, it's proportional to what you make, and it varies, basically. Does it work with SVG, exported from Inkscape or CorelDRAW? There we go. It renders JSON. It renders Lottie JSON. But there are some docs on airbnb.io/Lottie for how to convert your SVG to Lottie. So definitely possible. There are docs. Go check them out. Heavy animations and lower-end Android phones. What is the recommended optimization strategy? I already kind of covered performance on low-end phones. I mean, generally, these things perform pretty well. Lottie is supported down to API 16. We've tested them on low-end devices. Even back then, they're pretty optimized, and a lot of these animations are, at the end of the day, just drawing like various relatively simple shapes. Even if the animation looks impressive, it shouldn't be too bad. Again, depends on your animation. You have to try it for yourself. Size difference between OPNG-based animation and the Lottie version. I don't remember for the specific loader that I showed on the stage, but earlier on, I did show for the actual city animation. It's a 230K JSON. The equivalent at 2x or XX HTTPI PNG sequence was 1 or 1.1 megabytes. And again, that would be pixelated, and you have to load them all into memory. There's a lot of thrashing, a lot of problems, especially on low-end devices. So it's a big difference. And if you go to 3x or 3x HTTPI, you're going to run into a world of problems. React animation. So I have to be honest, I'm not super familiar with React animations. If you want to talk more about that, maybe we can talk. I'll stick around for a few minutes after, for sure. There was Facebook keyframes. They built that for Facebook reactions. That was a purpose-built tool for reactions. It supports just a tiny fraction of the features that Lottie supports. On mobile, there's really, honestly, nothing that competes to its support, compatibility, also flexibility. Except for potentially vector drawables. That's a good question. So on Android, there is native support for some vector drawables. So Lottie does not use vector drawables. It is its own thing. And some of the pros and cons, if you're considering vector drawables, are for vector drawables, they do run on the render thread, which is something that they have the advantage of being able to do on Android because they're part of the platform. It's not something we can do, so Lottie animates on the main thread. But if your animation runs at 60 FPS, it's not too bad. But you lose all the advantages of cross-platform. They basically just have play and pause. You lose all the dynamic properties. You can't seek it. You can't tie it to progress. They're, again, not cross-platform. So use them if they work for you, but you can do a lot more stuff with Lottie. All right. Thank you, guys.
Gabriel, thank you so much. This is super exciting stuff, and I think you nailed the day. So it was really, really, really interesting.
Thank you.
Here's one little present for you. Hope to see you soon.
Okay, thank you very much.
Thank you.
Yeah, and I'll stick around. If you want stickers or whatnot, I have some.